Let's take a look at this integral. There are many things you could try. You could try substitution and integration by parts, which I did and succeeded at neither of them. And so I thought it might be good to use integration by something I found on a table. One of the things I found on a table was this integral, which in some sense matches the one we're trying to do, except not really in the numerator. You'll notice our numerator is an x plus 3. So then I had a clever thought. What if I took the original problem that we had and broke it up as a sum of fractions? By doing this, I could then integrate a sum as the sum of the integrals, thus breaking this one integral into two. And it turns out each of these integrals, along with the help of the table, one number 16 at the bottom, is pretty easy to do. The first integral in the sum is not doable by any of the things I found in the table, but luckily it is doable with a u substitution. So what I did was I took this integral and I chose u to equal the denominator. And as you probably recall from substitution, you differentiate your choice of u and solve for dx. The purpose of this, as you'll recall, is that you can then plug the dx back into your integral. And now you have an integral in terms of du. I can, of course, also replace x squared minus 7 with u, since that was my original choice. And now what happens is the x's cancel, and I can factor out a 1/2. And then I can use the fact that the integral of 1 over u du is the natural log of the absolute value of u. Then replacing u with its original meaning, x squared minus 7, I'm now done with that integral. I technically should have a plus c at the end of this, but I'm going to get a plus c from the second integral anyways. There's no reason to write it twice because the sum of two constants would just be yet another constant. So I'm now done with the first part. Let's turn our attention to the second integral in this sum. Technically, that is not applicable to the formula number 16 because our numerator is 3 and formula 16's numerator is 1. But this is a problem that's easily solved and almost really ignored by just imagining that I could factor a 3 out of this integral and then I'd have a 1. I won't bother to do all that here, but it's something worth noting. So using this formula, I can take this integral, imagine that the 3 is factored out, and replace 7 with radical 7 squared. And while that may seem like a strange replacement, it's probably a good idea because I can now know that a is radical 7. After all, I had to have, according to formula 16, I had to have my denominator in the form x squared minus a squared. So now that I know that a is radical 7, I can plug that into the right side of this formula, and I'm now done with the second integral. And now that I'm done with both integrals, I have my answer.